Today we will start two-port analysis, its introduction and analysis of different two ports. This topic has a lot of applications. For example, like transmission of power, electrical power, that's a transmission line. We use ABCD parameters. And if we use ordinary transmission lines, there also we use most of the time Z parameters. In electronic analysis, we use H parameters. So this two-port analysis has lots of applications. So we will try to introduce this, then and see how different problems are solved. First thing, the topics. Definition of two-port parameters. What are the definitions? Then I will take you to conversion of two-port parameters, how to convert one parameter into another parameter. Then conditions for symmetry. Symmetry means the input and outputs, if the impedances are equal, we call symmetry. Reciprocal also we see the conditions. Reciprocal means the transfer impedances are equal. Then sometimes we talk about connecting one two-port into another two-port. For example, we may connect in parallel, we may connect in cascade, like that. Then calculation of two ports is the main idea, because in this we have 6 topics almost. So when we go through this calculation of two ports, then we will see most of the examination questions. Then finally, introduction to network functions and synthesis. So these are the basic topics we are going to cover. It will take at least 3 lectures. Today we will cover first 5 topics and 1 lecture completely on 6th topic and last lecture on 7th topic. So this is our approach for this big topic, which is the last topic of networks. Let's go for the definitions. Two-port network consists of 2 terminals for input and 2 output. These 2 terminals are called input terminals. These 2 terminals are called output. But please observe, I1 is entering, I2 is also entering. Why these 2 currents are entering? Actually, if one is entering, other should leave. But here, sometimes we put the signal here, then it acts as a load. Sometimes we may put the signal here, it acts as a load. That means when you are using it as a transmitter, this is used. When you are using as a receiver, this is used. So transmitter here, receiver here. Understand? Then voltage polarities are same, but current directions are opposite. What for? For this to act as a transmitter and receiver, as I just said. Because most of the networks are bilateral. Bilateral means 2 sides. When the network is bilateral, you can transmit this side as well as other side. That's the meaning of this. Then I am going to parameters one by one. The first and foremost important parameter is called Z parameter. Z for impedance. It is also called open circuit parameters, because by opening current, open circuit means current is 0. By keeping I2 0, you get this parameter. That's why it's called open circuit also. So this parameter has 3 names: Z parameters, impedance parameters, and finally open circuit parameters. There the dependent variables are voltages, independent variables are current. I am going to give you one very important, very interesting conclusion. Look at here, why do I call this? See, voltage and current. Voltage by current is what? Impedance. That's why we say Z. But what is this number? 1, 1, 1, 1. 1, 2 current. So 1, 2. 2, 1, 2, 1. 2, 2 here, 2, 2. That's how the impedances are being brought here. So V1, V2 are dependent variables, I1, I2 are independent. The way you have to number them, arrange them, even to remember, I told you the secret. Even here also same. 1, 2, 1, 2. And 1, 1, 1, 2. 2, 1, 2, 2. That's how the parameters been brought. If you know the simple secret, writing any parameters is very easy. If you miss this sequence, you may have to mug up so much and it will be wasting a lot of time. That's about jet parameters. And what are the names that we give? For example, if you put I2 0, V1 by I1. So I should call, when output terminals are open, that means I2 0. This impedance is called 1 1. That's why it's called driving point impedance. Driving means same port. But driving point at which one? Input port. So Z12 means one to the other. So it is called transfer. Z21 means again second one to the first one. So that's also transfer. Z22 means output to output. So it's called driving point impedance at output. This is at input, this is at output, then in between we have transfer. So these are the definitions, these are the way that they've been named also. Now let me take you to Y parameters. Y means admittance. That's why it's called admittance parameter. By keeping voltage 0, we get these values. That's why it is also called voltage 0 means short circuit parameters. That's why Y parameters are called admittance parameter, also short circuit parameter. Now get the definitions here. I1 V1, so it is Y11. I1 V2 Y12. I2 V1 Y21. I2 V2 Y22. So current is dependent here, voltage is independent. So this is about Y parameters. Just like Z parameters, you can understand. This is called driving point input admittance. Then Y22 is driving point output admittance. This is transfer. This is also transfer. So 1 and 2 is transfer. 1 and 1 is driving point. 2 and 2 driving point. Then let me take you to third parameters, H parameters. It's called hybrid. You know why it's called hybrid? Because one is impedance, other is reverse voltage gain. This is forward current gain. This is admittance. So each one has a different dimension. Impedance is there, admittance is there. Voltage gain is there, current gain is there. So many varieties are being mixed up, so they do not know what to call it except calling as hybrid, because hybrid generally means mixing of so many. So numbering is of course same, 1 2 1 1 1 2 2 1 2. These are the definitions we have. Then if you want to name them, that's very important. This is voltage by current, input impedance. Voltage by voltage, but input by output, reverse voltage gain. Output by input, this is current gain. Forward gain, because when I say forward, output by input. When I say reverse, it is input by output. Whereas the last one, I2 by V2, that means it has a parameter of admittance, current by voltage. So these are the definitions of H parameters. Then automatically you will get G parameters. Please understand, Z and Y are inverse, G and H are inverse. So this is inverse of H parameters. That means what? Whatever the independent is here will become independent there. So they can just interchange. So I1 V2. The way to write is very simple. 1 and 2. Here also 1 and 2. 1 and 2. So 1 1 1 2. 2 1 2 2. It's very easy to remember. 1 2 1 2. See 1 2 1 2 1 2. So very simply speaking, there are 4 values. Out of those 4 variables, 2 will become independent, 2 will become dependent. So that's the meaning of what you have, and it's called G parameters. Okay. Then we will go for what is the meaning of G. This is again same. This is called input, this is called output, these two are transfer. So that's how we can go for transfer means voltage gain, current gain, that's like that we get. Then ABCD parameters, that is also called transmission parameters. Why it is called transmission parameters? Because they are very much used for transmission lines. If you want to use in transmission lines, what happens is V1 and I1. Because transmitter means first port. From first port to second port transmission. Inverse means second port to first port. So both you should take one. We should, so far we have been taking 1 2. Now we should not take 1 2. We should take 1 1. But instead of both currents and both voltages, we will take voltage. So first port voltage, first port current. Then they are being transmitted. That's called ABCD. ABCD. That means where V1 and I1 are dependent, V2 and I2 are independent. Another important thing you should observe here, this minus 2, you know why minus 2? Because this current is coming this way. When the current is coming this way, the load if you put, it will be minus. So when you connect the load here, this current is called minus. Observe that. Another important thing I have to bring to you, we normally call ABCD. Why should we call ABCD? So far we said Z, Y, H, G, each one having 4 parameters, 1 1 1 2 2 1 2 2. But why not we do the same thing here? We do the same thing here for one reason. We cannot do there because this is 1 and 1, this is 2 and 2. Then how can you maintain the numbers here? Suppose you want to maintain the numbers, so for example, because it is for transmission purpose, if I call it as T, then what should I write here? 1 2 T, suppose T1 2, 1 2, this is also T1 2, 1 2 T1 2, 1 2 T1 2. So T1 2 here, T1 2 here, T1 2 here, T1, everything is becoming one parameter. That's why writing 4 parameters with one symbol is not possible. So we have decided to take each one separately. We have no other option. When we take each one separately, then you may take the first 4 letters of ABCD or last 4 letters of ABCD. Doesn't matter, but you must take 4. Therefore, normal approach has become, why not we enjoy ABCD? Therefore, they call that as ABCD. The ABCD parameters are only telling one thing. We can't put with one letter. Suppose you can say, you cannot say A11, A12, A22. That's not possible. You have to take separately. This is the meaning of what you call ABCD parameters, right? So this is the next parameters. The last parameters is, but here you can as well talk about what is A, V1 by V2, B, V1 by I2, C, I1 by V2, I1 by I2. How do we understand, what are the conditions? Very simple. If you want A, put I to 0, V1 by V2. If you want B, V1 by I2. Like that, by keeping one of the values at 0, you can always calculate the other parameter. So for example, you want A, V1 by V2, that's called inverse voltage gain, but with I2 0. That means output short circuited, inverse voltage gain. Output short circuited, this is I1 by V2, that means admittance. Like this, you can name your definitions very simply and very clearly. This is about ABCD parameters which are used in transmission parameter. For example, if you see EEE students, they have most of it ABCD parameters in EEE. Similarly, if you could see electronic students or even electronic circuits, transistors and analysis, it's purely of H parameters. So transistors are analyzed with H parameter, whereas transmission lines parameter analyzed with ABCD. These are very interesting applications. That's why this chapter or topic has become not only important for the exam, but more for the industry and day-to-day applications of engineering. Then the last parameter, A dash, B dash, C dash, D dash, that's basically inverse transmission line. These parameters can be defined as V2, A dash, V1. You please observe, whatever the dependent was earlier, now they became independent. Whatever the independent earlier became dependent. So now that means you are giving input here, the load is at here. So V2, I2 are dependent variables, V1, I1 are independent variables. Okay. So this is called A dash, B dash because they are the inverse of ABCD parameters. So this is how I could introduce, and you can also see what is A dash, what is B dash, what is C dash and D dash. So So these are the definitions you can go through, and these are the parameters we have. So this is called ABCD parameters. We have just introduced the parameters and we are ready for going into conversion of parameters. First, having done the definition part, we can do anything here. How to convert them from one place to one parameter to other parameter. Conversion of parameters. I have divided this into two cases. Case 1, within the pair. As I told you, there are 6 parameters and each one has another pair. Therefore, if I convert into pairs, we have totally 3 pairs. Z and Y is one pair, H and G another pair, ABCD and inverse is another pair. That's why each one is an inverse to the other. So we can directly go for inverse actually. So if it is within the pair, the problem I took is, the first problem I am starting, find the Z parameters in terms of Y parameters. So whenever people are asking you parameters into another parameters, we don't need to feel any difficulty. It's simply high school mathematics. You convert one into the another. If 2 equations are given, another 2 equations are given, is it difficult to convert them? Conversion is very easy. So see that what is unwanted, you replace them. That's all we have to do. For example, write the Y parameters that as we define. Write the Z parameters as we define. After writing them, if I have to go for matrices, V1, V2 is Z1, Z2. So V1, V2, Z parameters into I1, I2. I1, I2 is Y parameters into this. So what can I do now? Suppose if I want V1, V2 here, so this will go down. That means 1 by. That's why if you compare the first and the last here, you can simply say Z matrix is inverse of Y matrix. That's what it is. This is the proof to understand Z matrix is inverse of Y. If Z is inverse of Y, automatically Y is inverse of Z. Got it? And what do you mean by inverse? You know what it means by inverse. Z11 is Y22 by delta Y. Z12 is minus Y12 by delta Y. Z21 is minus Y21 by delta Y. Z22 is Y1 by delta Y. Where the delta is Y11, Y22 minus Y12, Y21. So this is what we mean by the conversion from one parameters to other parameter. Similarly, you can say H and G are inverse. And also you can say ABCD is inverse of ABCD. Right? That's it. Let me take you to case 2. Case 2, I mean outside the pair. That means one from the Z, other from the H. Okay? So I took the problem as find the Z parameters in terms of H. So that means you should take the H parameter equation and adjust them into Y. So a new word I have brought here, it's not a conversion, it is an adjustment. So adjustment of parameters or adjustment of equation is a very easy word, right? Now take Z parameters equation here, take YH parameters here. What you need to do, you have to adjust this into here. So V1 is allowed. Okay. I1 is also allowed. And what is not allowed? V2 is not allowed. So this V2 you need to replace from this equation. For example, what is V2? I2 minus H21 minus I1. I2 minus H21 I1 by H22. So take this V2 and substitute there in the place of I2. So that is how what is not required you please eliminate. And if you eliminate, you will get these parameters. You just see here as I am going for the solution, V2 is I2 minus this. So if I write this 1 by H21, H22 I1, 1 by H22. Now what is that here? This is, if you write the equation V2, you can comfortably say this is Z21. See there? Z21. This is Z22. This is Z22. So that's how we can convert this equation. Similarly, if you write V1, H11 I1, H12, actually we have V2 here, we are converting again. So if I convert, if I put this value in the place of V2, then what do I get? H11 minus this by this. If you really take a LCM, you will get delta H. So this is delta H by H22, that is Z11. H12 by H22, Z12. So like this, very simple task. Even if you forget, you can do in the examination. After all, we are finally targeting on exam. In the examination, you can do this process, right? So go for adjusting one equation into another equation. That's all required. Similarly, you can think of ABCD in terms of Z and Y, H in terms of Y and Z, ABCD. This is for your reference, and you can solve by yourself and prove it, and take time to really derive and then cross check. So this is what I mean by conversion of parameters. Then the most important condition in two ports is condition for symmetry. Why symmetry is required? Symmetry is to tell you whatever the impedance you have here, there is same impedance here. If the impedances are equal, you can exchange them. That's why you can use transmitter as a receiver, receiver as a transmitter. So we need to understand what it means by symmetry and what it means by what you call this definition. A network is said to be symmetric. The equivalent two-port parameters of the network should satisfy the symmetric condition. What is the symmetric condition? As I said, input impedance is equal to output impedance. When the input impedance is equal to output impedance, we call it as symmetry. Symmetry, you normally see these two eyes are symmetry, these two are symmetry, ears are symmetry. So symmetry is there most of the time. Even two hands are symmetry there. So symmetry we need to do. What is the procedure for calculating the condition? Calculate V1 by I1 with I2 0. Calculate V2 by I2, I1 0. Then equate these values if after equating and get a symmetric condition. But generally in the initial days, students have objected it and they said, sir, this is valid for Z parameters. This is Z11, this is Z22. You are assuming Z11 and Z12, Z22. Z11 means V1 by I1, Z22 means V2 by I2. If these two are equal, you are saying it is symmetric. But is this procedure valid for every other parameter? My answer is yes. So though the initiation came from Z parameters and they are valid for anything. In fact, if Z11 is equal to Z22, if you convert the parameters, won't you get that? So that same thing we are going to do directly. Instead of taking Z11, what is this value in terms of Z11? What is the ABCD parameters in terms of Z22? We don't want to waste our time. We'll simply apply this procedure. I'll show you what is really happening here. Look at here, obtain the symmetric condition for Z parameters. For example, here, this is the equation valid. Put I2 0, you will get Z11. Put I1 0, you will get Z22. Therefore, symmetric condition is Z11 is equal to Z22, which is called input and output impedance have the same value. Same value. So this is the third problem. Though I am covering the concepts, I am maintaining the problem number sequence there. You just follow. So as I have been telling, there are two types of problems. One is called illustrating the concept. I call them as illustrative problems. The other one is to test your concept. I call them as exercise problems or previous exam papers. So first understand illustrating examples. Let me take you for fourth one. Obtain symmetric condition for H parameters. So what to do now? Just write the H parameter equation. Put I2 0, get V1 by I1. Then put I1 0, get V2 by I2. So look at here, if I2 is 0, what happens to this equation? 0 is equal to H21 I1 plus H22 V2. So V2 becomes minus H21 by H22. So we need to calculate just a relation there. Take this relation V2 and substitute in the first equation. V1 is equal to H11 I1, H12 V2. What happens now? If I substitute this equation here, you will have V1 H11 I1, H12 with this value. That will become V1 by I1 is equal to delta H by H22. That is your Zi or Z11. We will not call it a Z11 because we may confuse it as a Z parameter. That's why Zi. Then put I1 0, calculate V2 by I. That will be very straight, because if I1 is 0 here, this term goes. V2 by I2 becomes 1 by H22. Very simple now. Therefore, you get 1 by H22. Take these two values and equate for symmetry. Delta H by H22 is equal to 1 by H22. Therefore, H22 will cancel. Delta H is equal to 1. So delta H is equal to 1 is the answer that we have. Right? So this is about symmetric condition. So I have done some problems on symmetric, then I'll take you for another problem. Obtain the symmetric condition for ABCD. For ABCD, what happens here? V1 is equal to this, I1 is equal to this. What to do now? Very simple thought. Put I2 0, get V1 by I1. That's nothing but A by C. If it is A by C, that is the first answer. Put I1 0, what is this? D by C. Therefore, A by C is equal to D by C, CC will cancel. Therefore, A is equal to D. This is a symmetric condition for ABCD parameter. Please remember, one I did for Z parameters, that means Y parameters also same. One I did for H parameters, that means G parameters also same. One I did for ABCD parameters, then A inverse ABCD also same. So out of the 6 parameters, for 3 I have done, that means the other 3 will follow. That's all about what you call symmetric condition. Similarly, these equations are given. Why? Because as I said, whatever is valid for Y is valid for Z, whatever is valid for G, valid for H, and ABCD is valid for inverse. So whatever that I have derived earlier in the 3 problems, the same thing is maintained for other 3 parameters. That's how you can conclude what you call symmetric. Now let me take you to condition for reciprocity. A network is said to be reciprocal if its characteristics are same even if the input and output positions are interchanged. That is, the ratio of excitation to the response is remains same. This is what actually we studied in reciprocal theorem in networks. When I was talking about theorems, I discussed this point. The network will satisfy the reciprocity theorem. That's what I mean. And therefore, now how to check it? I gave a procedure. V2 by I1, I2 0, I1 0, V1 by I2. In fact, it is just like Z21, Z12. Equate these two and get the condition. So there in symmetric Z11 is equal to Z22. Here it is Z12 is equal to Z21. And these are the procedures that we have in this. Okay. So this is what I mean by the word, what you call reciprocity condition. Why don't we check in some parameters? Obtain reciprocity condition for Z parameters. Define the Z. Now what does it mean? We are going to say now, put I1 0, I2 0, get Z21. If I1 is 0, you will get Z12. Z12 is what? V1 by I2. What is V1 by 2? Z12. Put I1 0. When you put I1 0, this will come. When you put I2 0, Z21. So get Z12, Z21. They are equal. That's why it is called Z12 is equal to Z21 is a condition for reciprocal. In fact, the procedure is developed upon that only. That is for Z parameters. Now what about for G parameters? Take G parameters and check for reciprocity condition. First define them, put I2 0, get V1 by I2. Put I1 0, V2 by I2. So V1 by, when you put I2 0, V2 by I1 becomes G2 1 by G1 1. When you put I1 0, V1 by I2 becomes minus G1 2 by G1 1. For reciprocity, if you equate them, you are getting G12 is minus G12. That means whatever is valid for G parameters, as it's also valid for H parameter. So that is called reciprocal condition. Okay. So next, obtain ABC reciprocity condition for ABCD parameters. Just take the ABCD parameters, put I2 0, solve for V2 by I1. Put I1 0, solve for V2 by I1 0 means we have to go for V1 by I2. So V1 by I2 here, AD minus BC by C, V2 by I1 is 1 by C. AD minus BC by C, 1 by C, how much? AD minus BC equal to 1. So this is the condition for reciprocal condition. Okay. So when you see that condition, reciprocity, same thing is valid for inverse ABCD also. So these are the conditions. Similarly, same thing valid for whatever is valid for Z is valid for Y, whatever is valid for G is valid for H, whatever is valid for ABCD valid for inverse also. So this is how the conclusion comes. For your clarification, I have brought all of them into one. Type of the parameter, symmetric condition, reciprocity condition. Z parameter, Z11, Z12, Y11, this is same. Z12, Z21, Y11, Y12. DH, delta H is equal to 1, delta G is equal to 1, A is equal to D, A is equal to C. And then whatever is valid for H parameter is valid for G. Whatever is valid for ABCD is valid for A inverse. I am also telling one more small thing. This is delta H, this is delta ABC. So H parameters symmetric is similar to reciprocity for ABCD. So that also you can enjoy. Here is this. A is equal to D, H12 is equal to H21. So if you want to remember, you can try with that way, or don't worry. Even if you forget, you can do in exam within 2 minutes given. Because max generally 1 minute to 2 minutes are given in the objective exam, you can derive if you remember my procedure. So what is the procedure? Symmetric, V1 by I1 is equal to V2 by I2 for any parameters. Get the condition there. What is reciprocal? V1 by I2, V2 by I1. Equate them, get the condition. If you remember these two words, you can comfortably do this job. The whole symmetric condition and reciprocal condition is in your hands. You can just directly enter the exam hall. So this is about symmetric and reciprocal. Then the last thing for today is interconnection of circuits. How to connect them? Interconnection. What is interconnection there? Suppose there is a network A, network B. If two networks are here, they are connected in series. Please remember, if networks are connected in series current is same, voltage is different. If current is same, voltage is different, so what is going to happen now? Voltage is going to depend on current. Voltage depends on current. What does it mean? It simply means Z parameters. I gave one small idea to remember. Identify the dependent parameters or independent parameters. Just identify the independent parameter. Then you can automatically tell what is the overall parameter. For example, for this one, Z parameter of A, Z parameter of B get added. Why they are added? Because voltages are added. That is called series, because input side it is series, output side also series. Then series and parallel. Suppose series and parallel, here voltages are added, currents are added, because in series voltage is added, in parallel current is added. Therefore, my dependent parameters V1 and I2. If V1 and I2 are added, what's going to be the parameters without doing anything? It's going to be H parameters. See there. So H parameters will help you. Depending on the dependent parameters, I am going to conclude without doing any work. Identify the added variables as dependent. They are added. If dependent is added, identify them. So for the next one, I will just tell the topology, you tell the meaning, you tell the identification. Now what about this? Look at here. Input is parallel. What is added? Current is added. Output is series. What is added? Voltage is added. Input means I1. I1 is added. V2 is added. I1 and V2, which parameters is that? I1 and V2 as dependent, which parameters is that? That is nothing but G parameters. So, next one, parallel to parallel. If input is parallel, output is parallel. What is added? Current is added the input, voltage is added the output. If two currents are added, input is parallel, output is parallel, means input current added, output current added. Added parameters are dependent. That means I1, I2 are dependent. When I1 and I2 are dependent, you know what's going to happen? If I1 and I2 are dependent, and that's nothing but simply admittance parameters. So this is called how to identify just by looking at the topology. Lastly, cascaded connection. These two are cascaded. When you cascade them, that is ABCD parameters comes into picture. Therefore, look at the different topologies, identify the dependent variables. According to the whatever is added, that you identify as dependent, parameters will come. So this is how you are going to use this technique called interconnection even for analysis of parameters. Good. Now I am taking you to problems. So far in the sixth problem over, now we have question number 7. Calculate Y parameters for the bridge network shown in figure. This is called bridge network. You know why? Because this is a T, then T is bridged with 1. So it is a bridge T, you can call actually. T is bridged with one component, right? Now, what do we do here? The best thing you do is, this lower one is one circuit, just upper one is another circuit. If lower one is one circuit, upper one is other circuit, they both are connected in parallel. So calculate Y parameters of the lower one and Y parameters of the upper one. If you have the Y parameters of the upper one and Y parameters of the lower one, if they both are added, overall parameters will come. So that is the meaning of this analysis. That is, now this will simply called parallel configuration. Parallel. So take this circuit, please find out Y parameters. Why should I find Y parameters? Because parallel, it is Y parameters added. Because parallel get added means what? Parallel current is added. So I1, I2. I1, I2 means nothing but Y parameters. So take Y parameters of this one and take Y parameters of this one. When you take Y parameters of for this, you can simply say After adding these two, you will get the overall. That is the purpose of connection of two ports. When we are connecting two port networks parallelly, the overall will come. Finally, the overall is A, B. Y11 of A, Y11 of B. Y12 of A, Y12 of B. Y21 of A, Y21 of B. So these are the parameters you have. These are the parameters you need to calculate. So that is how we are using the topology and the parallel combination there. Different parallel combinations are presented there. Okay. Now, two-port networks are connected in parallel. There are two-port networks connected in parallel. The combination is also represented as one two-port network. Then the parameters of this circuit are obtained by addition of what? As I told you, two parallel is connected. Parallel means what? Currents. Currents is dependent. When currents are dependent, what happens is you will have Y parameters. So that's why you look at that. Y parameters is the answer. So this is given in the GATE exam, asked in 1988. Follow that. Then the condition AD minus BC is 1 for true port implies that the network is what? Reciprocal, symmetric, lumped element, lossless. First of all, forget about this C and D. Then you are only with this. And if we already derived, if you compare the table also available, then it is reciprocal. So how to do that? Suppose you have forgotten that table, or if you don't remember, then you take what? Very simple. Take A, B, C, D parameters, try for the reciprocal. If it's not successful, go with the symmetric. So it takes 1 minute or 2 minutes maximum to solve it. That's why you can comfortably apply the procedure for reciprocal, procedure for symmetric. So answer is direct reciprocal. Question number 11. Two two-port networks are connected in cascaded. The combination is also represented as one two-port network. Then the parameters of this network are called obtained by multiplication of what? As I just told you, cascading is nothing but multiplication of ABCD parameters. So look at here. All the four are there. Z is there. Y. Actually, they don't need to put 2 because if Z is true, Y is also true. Right? So better is ABCD. Cascading is by ABCD. I'll tell you one by one. Z parameters series and series. Y parameters parallel and parallel. ABCD cascading. H parameters is what? H means what? V1, I2. Input is added. That means series and parallel. Like that, you can as well put the reverse concept also. So this is also asked in the exam. I am just showing you examination problems because you need to see how much we studied is useful or not. Otherwise, it will become too much of theoretical thing like BTech, but in competitive exam, we need the highlights of theory and more problems there. Answer is D. 12. For a two-port network to be reciprocal, what is the condition? Z11, Z22, no, this is symmetric. Y21 is Y12, yes. H12, H22, no. AD minus BC, just now we studied reciprocal. This is also reciprocal. This is the only for symmetric. So answer is B. So this is how we go for checking all the conditions. Question number 13. For the Y parameters given, Y11 is 0, Y12 is minus 1, 2, Y21 is 1 by 2, Y22 is 0. If all these parameters are given to you, can you cross check what I am saying? What is this circuit basically? Is it non-reciprocal circuit? Active, non-reciprocal, passive, reciprocal and active, reciprocal and passive. What exactly mean? What do you mean by the word? Reciprocal, you already studied. What do you mean by passive? Passive means you don't get more. So it is basically admittance is less. That means impedance is more. It is not reciprocal. You know why it is not reciprocal? In reciprocal, y12 is y21, but we have a negative sign. Therefore, it is non-reciprocal, but it is active. So these are the definitions you have. Now 14. If a two-port network is reciprocal, then we have the relation. Now he is checking the reciprocal condition. See there? How many questions are coming on this? Just on the reciprocal and symmetry, you have lots of questions. That is, H12 is H21, H12 is minus H21, H1. Because reciprocal means, as we derived in the previous, procedure, you can just put it, and that's going to be B. Just you have seen the table. That's why better remember the table. It saves you a lot of time. How to remember also I told you. Z11, Y11. Z12, Y12. Whatever is valid for Z is valid for Y. Whatever is valid for H parameters in reciprocal is valid in ABCD in symmetry. That way also you can easily remember. But ultimately my suggestion is practice will make you better. Practice will give you the confirmation and no doubt. Otherwise you will have a doubt at every step. Practice it and then remember by practicing. Don't remember just like that. So that is now option is B. So if a two-port network is reciprocal, then we have the relation, that is B. The ABCD parameters of an ideal n:1 transformer respectively, what is it? This is a given ABCD parameters. A is equal to 1, B and C are then. What is the K? He is simply asking the value of K. This was 2005. Answer is very simple. When you talk about network elements, we have two types of elements. The best examples are ABCD, you have a transformer, and for H parameters you have transistor. So we need to do these two elements. The best examples for elements are transformer and transistor. Now what best you can do is you just take equations of a transformer, adjust that equations into ABCD. But please understand this current is coming in this side. Actually in a transformer it goes opposite. So minus sign we must take here. That's good. Observe the solution. Very simple. I2 by I1, V1 by I2, N2 by N1. So if you do this one, and you can say these equations, adjust this, V1 is equal to N into V2, I1 is equal to 1 by N into I2, and as you know equations, V1, AV2 minus BI2, I1, CV2 minus DI2. So what is in the place of D? You look at here, you in the place of D you have 1 by N. So the option is 1 by N. 1 by N is the option here. So this is the equation, just a transformer equation, that's all, nothing else. Now I am taking you to one problem called transistor problem. If two-port network shown in figure below, calculate Z12, Z21. 2006, 1 mark. See, such a big question you may feel 1 mark is very less. Don't worry. It has only two ways. Simply apply KVL here, apply KCL here. Don't try to remember any procedure. That is 0, this is 0, this is 0. That just apply. By keeping 1 0 getting other values, getting another 0 getting other two values, that's the old procedure. But now I always go with just whatever equations possible apply. Like in the previous, I have used the transformer equation. Just obtain the equations, adjust them into your standard equation required. Let them give any circuit. Just obtain the equation. From there, adjust into the circuit. So when you adjust into the circuit, that finally comes very easily. So what I'm going to do is, I'm going to apply KVL here, KCL here, and then automatically identify. So some people call calculating the values, but I termed it as identifying, right? Apply equation, V1 is IE into RE. So what is the value of Z11? So you look at here, 0. I2 is equal to beta I1 and V2 by R2. So V2 is equal to minus beta R1 I1. So this. So he is asking what values here. Compare this. In the place of Z12, how much is here? 0. In the place of Z21, how much is here? Minus beta R2. So these are the two answers. And if you see the answers here, 0 minus beta R0. So option is clearly B. So look at the option there, B. 17th problem. Calculate Y parameters for the network shown. I am calling it as twin T. You know why it's called twin T? The lower one is 1T, upper one is another T. So those two are mixed. That's why it's called twin T, 2T networks. And lower one is a low pass filter, upper one is a high pass filter. If low pass filter and high pass filter are connected in parallel, what do we do it? Like we studied in the previous topics in the filters, I already talked to you. Low pass, high pass. There in the filters we talked about LC, but here I am talking about RC, doesn't matter. So low pass parallel with high pass or high pass parallel with low pass will automatically become what? Will automatically become what you call Y parameters get added. So what you can do is calculate Y parameters of each circuit, finally add each one. The respective components are added. When the respective components are added, we call it as best, easiest procedure. So I am going to divide this into two parts. This is one, this is another. And when I analyze them, the total will come. So addition of Y parameters of Y and addition of Y parameters of B is moot. That's about what you call calculating the parameters of parallel circuit. Then calculate the Z parameters of the network shown in figure. What I mean is, again, I am going to replace this transformer. I'll put I2 here. So this I1, this. If I use this transformer, first let me replace the transformer by using the transfer equation. Once I replace this portion, this will simply act as a L-shaped network. You can apply Kirchhoff's laws and find out whatever the parameters required. I always suggest for Z parameters KVL, for Y parameters KCL. Look at the equation I am going to solve. So I am going to replace this transformer I2 by N, NV2. Now I will take equation for loop 1, loop 2 and get the final answer. When you write the equations L1 and L2, I mean I1 and I2, you will get the equation. You see there how I have written ZA into ZB into, and that is equal to here. N into V2 is equal to ZB into this, and separate them. So in the place of Z11, I got this ZA ZB, Z12 ZB by N, Z21 ZB by N, Z22 ZB by N square. This is how, if a transformer is being given in the exam, you don't need to worry about it, draw the equivalent, push it off, and take only this portion of the circuit. Apply KVL for the input, KVL for the output. Input KVL will give us Z11, Z12. Output KVL will give Z21 and Z22. This is how you can calculate, even if there are what you call some other elements like transformer introduced, eliminate them by drawing the equivalent. So this is all about first talk on two-port analysis. The second talk that is left over is basically what you call, that is purely calculating parameters. What are the varieties of circuits we have, how to handle them, what are the approaches to calculate parameters. That itself is going to be one talk. Okay.